So it's been a few months since the lovably bizarre YouTuber Zach Friedman released his Gridfinity organization system, and I don't know about you, but as you can see looking around here, I've been hard at work Gridfinity-ifying my entire life. And in this video, I want to share with you some of the tips, tricks, and words of wisdom that I've come up with after hundreds of hours and kilos of filament devoted to this lofty project. Tip number 0, the magic of open source, community, variety, and innovation. So I'm going to get into the real tips and tricks in just a second, but first I want to point out that Gridfinity isn't just a standard for creating organizers. It's an open source standard and one that already has a community developing around it. For those of you who aren't in the know, a few months ago, Zach Friedman released the awesomely open source Gridfinity system, a pretty ballsy move considering that he was effectively building upon Alexander Chappell's closed source pay-to-download system and turning it into an open source one that anyone can use and build upon for free. Kudos to you, Zach. I love Alexander's work and I'm a big fan of his videos, but I have to say that within a few hours of Zach releasing his own files open source, it really became a case study in the benefits of open sourcing your project. Whereas Alex's community had to wait patiently for Alex to release even new box sizes, or suffer for months or years with design decisions that Alex made to suit his own workshop, such as non-square dimensions, within hours, an entire grassroots community had sprung up around Gridfinity, including a Discord community, a rich library on Thangs, and a subreddit, and much, much more. Zach himself even did a follow-up video showcasing some of the best designs created by the community, including many that far improved upon even his own wildly creative and sometimes scary imagination. In short, in just a few hours, this open source version of Alex's idea far surpassed 2+ years of Alex's own innovation, and we're just getting started. Now, that's not an indictment on Alex in any way. Frankly, he's more of a manly man, engineer, maker, and videographer than I'll ever be. It's just a simple fact. 1,000 brains are better than one brain, no matter how charmingly Swiss that brain may be. So on that note, tip 0, if you'll indulge me, is to make sure that you join the community on Reddit and Discord, because there are a lot of folks out there who can help you with your own designs, and I'm sure that you have a lot to contribute. Currently, some of us are planning out a more organized directory for finding Gridfinity parts on the new community-led gridfinity.xyz, but there's a lot of other ways to help, which leads me to tip 1, generate your own empty bins. Okay, no more quasi-tip foreplay. Let's get to the One of the really cool things about Gridfinity being so open source is that we don't have to wait for Alex, Zach, or anyone else to create new designs if we need them. In fact, we don't even have to design them ourselves, because believe it or not, there are already multiple different resources and files available for you to generate your very own empty bins, even if you have no discernible design skills whatsoever. Of course, even in his original video, Zach pointed out that his designs are fully parametric, meaning that you can modify them right in Fusion 360, which you can download for free if you're a maker. And yes, that is true. However, I found that the Fusion 360 version was lacking some capabilities, such as the ability to remove the label without knowing how to navigate the editing functions of F360, and I'm not a real maker, so I have no Fusion skills. Fortunately, a user named simply Jamie over at Printables went ahead and converted Gridfinity into an OpenSCAD library, allowing you to generate bins, base plates, and much, much more right in the OpenSCAD software. For those of us who aren't super comfortable with Fusion 360 or who are just lazy, also me, this is awesome because it means that you just need to edit a few parameters and you're able to generate any kind of box or base plate your little heart desires, at least for the basic ones. Initially, I had some issues with the top layers, but Jamie has been really quick and responsive in improving the files and updating them on GitHub and on Printables. So if you aren't seeing the sizes that you want, go ahead and check out this incredible resource. Tip 2. Create your own custom bins. Okay, that's cool, but what if you don't want just another empty bin? I mean, after all, the magic of Gridfinity lies in the idea that it isn't just about storing more stuff. It's about displaying your stuff in the most efficient manner possible so you can get more projects done. And sure, while there are tons of designs being uploaded every single day for an increasing number of tools, glue sticks, doodads, and thingamajiggers, you're almost certain to have some tools that nobody else in the Gridfinity ecosystem has. Fortunately, JDegs over at Printables has you covered. JDegs went ahead and uploaded a library of filled-in Gridfinity boxes for your customization needs. What good is a filled-in box, you ask? Great question. You see, with a filled-in box, all you need to do to customize is create a cutout in the shape of whatever you want. Effectively, you need to draw out the tool that you want to use in the Gridfinity box, and then use a Boolean modifier in Blender or similar functionality in another software to subtract away that shape from the filled-in box. Heck, you might even get lucky and find that someone else has already created a model of your tool. But remember to beef up the dimensions a little bit because you don't want it to be an exact fit in your Gridfinity box. By the way, if you want to see an example of this method in action, make sure to check out this nifty lie-flat caliper holder that I made based on JDegs' files, because unlike the dozen or so caliper bins available, it fits in a drawer, but also stands the caliper on its side, taking up half as much space as if it were laying flat. It also puts the caliper at a gentle angle, making it more convenient to pull out. And no, I didn't just melt a hole in the bottom of mine with a lighter because my prototype didn't fit and I didn't want to waste any more filament. Tip 3. Nozzle diameter. Originally, Zach recommended using a 0.6 nozzle or smaller, probably because that's what all the trendy cool kids are doing after Thomas Sandlandanderer effectively canceled 0.4mm nozzles a few weeks ago. However, many in the community, myself included, have actually had great results using as high as 0.8mm nozzles as long as we use the newer Arachne perimeter generation feature of Cura or Prusa Slicer Alpha 2.5. Now, in case you don't know, Arachne does a much better job of dealing with thin perimeters by adapting the extrusion mid-print, making it great for thin-walled prints like the bins of Gridfinity. And of course, a bigger nozzle means that you can print more Gridfinity containers faster, especially if you print at 0.4mm layer heights like I've been doing. Now, while it is possible to print with a bigger nozzle and a higher layer height, I do want to warn you of a few important things. First, because Gridfinity bins have a lot of large, flat surfaces, especially as you get bigger and bigger, you need to be particularly careful about your infill and layers. Initially, I figured that I'd go as low as possible with the infill, since the parts don't need all that much strength, but that was a big, flat, misshapen mistake. What ended up happening was that my first infill layer would warp and do all kinds of weird stuff, curling upwards and getting caught on the print head, and that led to, in the best case, awful surface finishes, and in the worst case, massive step skipping that caused entire prints to fail. The fix for this was actually just to increase infill to 15% in order to help that first top layer lay down buttery smooth. Which leads me to my second tip within a tip. Don't focus on the numbers here. For the first, honestly, 70% of the boxes I printed, I was using way too many layers for the top and bottom. And I think it's because I'm so used to printing with 0.2mm layer heights that I didn't really stop and think anything of it to see 3 and 4 layer settings for each of these. But then I took the boxes off the printers and they had heft, like serious heft. Oh, and I started running out of spools of filament. It's only then that I did the math and realized that between 4 bottom layers and 4 top layers, I was basically printing with 3.2mm of solid plastic for the part of the boxes that doesn't need any strength at all. So as you're increasing infill to 15%, I recommend decreasing the top and bottom layers to 2, maximum 3. Your pocketbook will thank me. Tip number 4. Some like it hot, Gridfinity is one of them. Personally, I'm one of those don't print it hotter than you need it types of guys, and I generally find myself printing PLA at 190 degrees in order to keep it from stringing. However, there is a strong case for printing these bins much hotter than you are used to. First, there's the issue of using a bigger nozzle, which means more filament flowing through in less time, which means you'll want more heat to ensure that you fully melt the filament. I found the most success at the top of the range, 220 degrees, and I lost a good few hundred grams of filament to lower temps. Additionally, there's layer adhesion, which I'll talk about more in a second, but for now, I'll do what all lazy pseudoscientists do and refer you to someone else who actually puts in the effort to do his own research. Stefan over at CNC Kitchen has done some great and awesome experiments to determine the best layer adhesion temperatures for PLA, and he's found that up to a certain temperature, higher temps in the range of 215 degrees plus do lead to better layer adhesion. But what about stringing, you ask? Well, first of all, Gridfinity bins are not that intricate, and for the most part, a bit of stringing is much better than bins that fall apart. What's more, you can usually get rid of that stringing with a hairdryer or just ignore it because it won't interfere with the usability of the bins, unlike layer separation. Tip 5, filament. I don't know about you guys, but whenever I see a big project like Gridfinity where print quality isn't going to be all that important, I immediately think to myself, yes, a chance to finally use up all that crappy filament I would never use for a paying client. Hold your horses, Sally. While Gridfinity is not that taxing on your printer, there are a few things that are cause for concern and which ultimately led to me wasting well over a kilo of filament trying to print and reprint bins. First and foremost, there's the problem I mentioned just a moment ago, layer adhesion. You see, because some parts of our bins will have just one layer when printed with a 0.8mm nozzle, it's important that we use filament that has no layer adhesion issues. I had two different filaments which I knew to be problematic, and upon pulling the bins off the build plate, the layers separated faster than a celebrity couple. For some filaments, you'll be able to resolve this by upping the heat or decreasing the fan speed, but for others, it's just not going to work, and you'll need to save this for a print where layer adhesion is less of a deal breaker. You definitely don't want those layers to separate when you're lifting a bin full of 100 tiny little screws over a nice thick carpet. Next up, there's bed adhesion. As Zach mentioned, bigger boxes can get warpy, and this can lead to your bins not sitting nicely inside the grids or your grids not sitting great at all. Most of this can be resolved with the classic PLA solutions, glue sticks, turning down the fan, and an enclosure, but I strongly recommend you have these things dialed in before printing bigger bins because unlike most PLA prints, using a brim is just not practical for a print like a Gridfinity bin, and removing that skirt would just be a nightmare on something like this. What's more, I also had a few rolls of filament that, no matter what, no matter the temperature, insisted on clogging up with all the retractions necessary to print the base plates, leading to tons of wasted filament and a lot of frustration as I waited to have enough base plates to start organizing all my crap. Ultimately, I'll say that although Gridfinity seems like a great way to use up crappy filament, truthfully, I found that it's better to just commit to buying more of the good stuff. I mean, the entire Gridfinity organization system is free and open source, so what's $20 or $50 on filament? Side note, I've had the most luck with the really affordable Overture PLA that you can find on Amazon. Not their Pro version, but just the regular one or even the Eco PLA that you can get for $17.99 right now. And I'd appreciate it if you used my referral link in the description to help support the channel. Tip 6, analysis paralysis. In his video, Zach jokes around that he has ADHD 4K 120 FPS. Well, I, like many of you, have OCD 8K 1 Gbps. So Zach's "don't worry about analysis paralysis, just print it again if you change your mind" did little to comfort my OCD brain. I thought about all the different sorts of ways to color code my bins and even tried to plan an Roy G. Biv rainbow vibe, only to realize that the modularity of this system made it inevitable that it would end up looking like my toddler's puke after Halloween. So instead, I decided to go with a theme-based color scheme using a specific color for each type of tool in my Gridfinity system. You see, part of the beauty of Gridfinity is that the bins are modular and can be taken out and moved and reorganized, so there's no guarantee that you'll want to put them back in the same place every time. Maybe while working on a woodworking project, you want specific tools closer to the forefront, or maybe after a particular scolding from your wife or significant other, you've decided to cool it on the real man tools and put the call-its further back in the drawer to save money on a divorce. The point is, if you set colors based on the type of tool, you'll not only avoid going batshit every time you see out of order color schemes, but also you'll be able to find tools faster and easier because you'll know what color you should be looking for, even if your eyes are full of acetone fumes and sawdust. You could, for example, go with purple, heating tools, blue, squirty stuffs, green, pointy boys, yellow, these nuts, orange, these bolts, red, things that go bump in the day. Yes, I know that list was still in color-coordinated order. No, I'm not sorry. Yes, I made up things that go bump in the day. And no, I'm not going to explain the logic. Because of course, each Gridfinity setup is as unique, illogical, and nerdy as its owner. Make it your own. Nobody else needs to understand your logic. Just tell them to appreciate the pretty colors. Art is in the eye of the beholder. By the way, speaking of art or attempts at making it, if you're enjoying this video and want to see me try and make more of them instead of giving up like 99.9% of new YouTube channels, the best way to do so is to subscribe and leave a comment below on another topic you'd like to see. I honestly have no shortage of ideas for creating more videos. The only thing stopping me is I'm not sure anyone else out there wants to see them. So let me know I'm not completely crazy by subscribing. Tip number 7, size isn't everything. Personally, I was initially motivated to print as big of a base plate as I could on my CR10, and then print the smaller ones to fit the remaining nooks and crannies. But in the end, I actually wish that I'd gone smaller for 2 reasons. One is that I had some serious issues with nozzles clogging on specific filaments, like I mentioned before. The biggest base plates were 7x7s or something like that, and I would waste 2 or 3 hours and a few dozen grams of filament before they'd clog up. Sure, I used Stefan's awesome tutorial for continuing failed prints to fix a couple of them, but a couple I failed to unfail my fail. Then there's the annoying stuff like warping during printing, breaking when you pull them off the bed, or the hot glue drying before you realize that one corner is a millimeter off, which will mean that none of the bins will fit properly in that entire base plate. Bonus sub tip, make sure you glue the grids in perfectly square, because slower drying glue and patience are greater than fast glue and millennial-like impatience. Eventually, when I got to printing those smaller ones, I realized how nicely the Gridfinity plates pair up with one another, and the edges are designed to be half the width of the inner divisions. Genius! And considering that the smaller ones print better, are less of a problem if they fail, are less of a hassle if you glue them in slightly crooked, in retrospect, I wish that I'd just broken up my massive drawer into lots of smaller ones rather than trying to maximize my print bed. Which is a good enough segue into tip number 8. Print one part at a time until you are certain. As you've probably gathered from my tips above, I had a lot, and I mean a lot, of print failures while I figured out the exact right settings for printing these bins with each of my types of filament. Plus, there are always the annoying everyday print failures that happen as a natural part of 3D printing. Filament gets stuck in your feeder router thingy, your filament runout sensor decides to take the day off, your nozzle clogs, or the 3D printing gods just decide to give you the middle finger. I wanted to do one of those dramatic pour out all my failed prints slow-mo shots, but I also didn't want my wife to leave me, so I threw out most of the failed prints before she could see how much money I'd burnt on filament this month. I like you guys, but I like her more. The point is, in my excitement to Gridfinity my entire life, yes, that's a verb now, I went about filling up my entire print bed with as many bins of a certain color as possible, only to wake up in the morning with 700 grams of useless junk. In retrospect, I really wish I'd just printed a few pieces at a time, taking my time to get it right until at least I had everything dialed in perfectly. Sure, it would have only saved me $20 or $30, but what's another day or two to wait, especially since I have a feeling my Gridfinity setup is never going to be fully complete, and I'm going to be printing improvements and changes at least for the next few months. So there you have it, my top 8 useful-ish tips for improving your Gridfinity success. I'd love to hear in the comments below, did I miss anything? And again, I want to remind you, if you'd like to see me try and make more videos like this one, please subscribe and leave me a comment letting me know that I should keep going. Thanks for watching and happy 3D printing.